Whether you live in Olympia, Washington like me, Kelowna, British Columbia, or Lethbridge, Canada, recycling bins are used throughout North America. They are so common and so widely used, they have become a part of our daily routines. For most of us, it's as simply as putting on slippers and walking the recycling bin out to the curb. But for the people of Lethbridge, Canada, this simple action can be dramatically different. Sites like these are all too common in Lethbridge, where wind speeds can reach up to 120 kilometers per hour, including environmental conditions of ice and snow. Recycling bins can tip over, spreading their contents across the street, as well as even rolling away. Luckily, a team at UBC Okanagan has designed an innovative, cost-effective, and simple design to solve this problem. Our innovative design has two main components, the bar and the latch. The bar serves three main functions. It shifts the center of gravity of the recycling can backwards. It reduces the likelihood that the can will tip to the left, right, or forward. And it stops the recycling can from rolling, which is a common problem with high wind speeds in Lethbridge.
Our solution to the problem is the implementation of a kickstand. This is the kickstand. It has four components. The bar is set up to swing along the radius of the wheels. The bar swings underneath the wheels, lifting them off of the ground and preventing movement. The bar also acts as a weight, weighing down the bin, increasing friction, and further preventing movement. The bar can be moved to a lowered position and then put into an upright position with the use of the handle attached to the bar.
In order for the kickstand to swing in the desired motion, we needed to create a latch that would maintain the proper pivot position. This simple piece of plastic is inserted into the bottom hole of the wheel section and points vertically to the point where the kickstand is able to rotate around the wheels. The latch extends perpendicular to the axle of the wheels and is latched onto it to hold the system in place.
The locking mechanism used in the kickstand is composed of a strong, thin, and flexible bar that leads to a locking piece on the top. When it's in its locked position, the kickstand is secured by the locking piece in the divot. After slight force is applied to the bar, it flexes out of the way and the locking piece slides out of the divot, where it'll rest against the flat surface of the bin. This allows for a smooth range of motion while not in its locked position.
The next portion of our design is the latch. The latch works simultaneously with the wheel bar to create what we believe to be the most effective solution possible. Its purpose is to ensure that the contents of the recycling bin aren't spilled onto the ground if it tips over. We believe this component is necessary to our build, as our wheel bar will increase the probability of the bin falling over. The latch is made from a small number of parts. Each part is either easily attainable from a hardware store or easily made up with the use of a 3D printer. This will ensure that our design remains cost-effective. Additionally, the latch doesn't require any difficult installation procedures, as it can be attached to the lid with a simple adhesive. Each recycling bin will need to be fitted with 2 of these latches to ensure the best performance possible.
The biggest problem we faced was how to create a latch that stops the lid from opening yet still allows the garbage truck to come by and empty the bin. We were able to do so by letting the latch move freely in space so that when the truck picks up the bin and rotates it, the latch will move out from under the lid and allow it to open. However, if the bin falls over backwards, the latch will remain in place and remain effective. Our wheel bar ensures that the bin will only fall over backwards through the use of clever positioning and weight. One must simply orientate the bin in the correct fashion relative to the road, and the latch won't inhibit the garbage truck from collecting the contents of the bin.